Welcome to Chapter 3. Now that we've learned about fractions and proportions, let's explore a powerful tool called the ratio box. This structured approach provides an efficient way to solve ratio problems by organizing our calculations visually. The ratio box is especially useful for complex ratio problems and will help you solve these types of questions quickly on standardized tests. Let's dive in. So, what exactly is a ratio box? It's a methodical approach to solve ratio problems efficiently. By organizing ratios and values in a structured format, think of it as a table that helps you visualize and calculate ratio problems step by step. In this example, we have a ratio of boys to girls, that's 3 to 4. The ratio box organizes our calculations visually, showing us the original ratio values, the multiplier we need to use, and the final values we calculate. This approach offers several benefits. It makes it easy to organize information, helps visualize the relationship between different parts of the ratio, reduces calculation mistakes, and works for both simple and complex ratio problems. Once you master this technique, you'll find ratio problems much more approachable. Now let's learn how to set up and use a ratio box. First, identify the ratio and the total value. For example, let's say we have a ratio of boys to girls that's 3 to 4, with a total of 28 students. Second, create the box structure. The top row will contain the original ratio values n3 and 4. The middle row is for the multiplier, which we'll calculate. And the bottom row will show the final values after multiplication. Third, calculate the multiplier. Add up the parts of the ratio, 3 plus 4 equals 7. Then divide the total by this sum, 28 divided by 7 equals 4. This gives us our multiplier. Finally, calculate the actual values by multiplying each ratio part by the multiplier. For boys, that's 3 times 4, which equals 12. For girls, it's 4 times 4, which equals 16. This gives us 12 boys and 16 girls, which correctly sums to our total of 28 students. This step-by-step approach is what makes the ratio box so powerful and clear. Let's work through our first example. The problem states that the ratio of boys to girls in a class is 3 to 4, and there are 28 students in total. We need to find the number of boys and girls. Step 1. We identify the ratio as 3 to 4 and the total as 28 students. Step 2. We find the sum of the ratio parts, which is 3 plus 4, giving us 7. Step 3. We calculate the multiplier by dividing the total by the ratio sum. That's 28 divided by 7, which equals 4. Now we can set up our ratio box. The top row contains our ratio values, 3 for boys and 4 for girls. The middle row shows our multiplier of 4. The bottom row shows the final values after multiplication. 3 times 4 equals 12 boys, and 4 times 4 equals 16 girls. Therefore, there are 12 boys and 16 girls in the class. We can verify this is correct because 12 plus 16 equals our total of 28 students. See how the ratio box keeps our work organized and helps us track each value clearly? Now let's look at example 2, which involves the surface areas of the USA and Brazil. The problem tells us that the ratio of the surface area of USA to Brazil is 10 to 9, and their combined surface area is 133 square units. We need to find the difference between their surface areas. First, we identify the ratio as 10 to 9 and the total area as 133 square units. Next, we find the sum of the ratio parts. 10 plus 9 equals 19. Then, we calculate the multiplier by dividing the total area by the ratio sum. 133 divided by 19 equals 7. Now we can set up our ratio box. The top row shows our ratio values, 10 for USA and 9 for Brazil. The middle row contains our multiplier of 7, and the bottom row shows the final values. 10 times 7 gives 70 square units for the USA, and 9 times 7 gives 63 square units for Brazil. Therefore, the difference in surface area is 70 minus 63, which equals 7 square units. Again, we can verify our answer by checking that the sum of the areas is 70 plus 63, which equals our total of 133 square units. Let's tackle our final example, which has larger numbers. The problem states that the ratio of boys to girls in a program is 61 to 48, and there are 327 students in total. We need to find the exact number of boys and girls. First, we identify the ratio as 61 to 48 and the total as 327 students. Next, we find the sum of the ratio parts. 61 plus 48 equals 109. Then, we calculate the multiplier by dividing the total by the ratio sum. 327 divided by 109 equals 3. Now, we set up our ratio box. The top row contains our ratio values, 61 for boys and 48 for girls. The middle row shows our multiplier of 3. The bottom row displays the final values. 61 times 3 equals 183 boys, and 48 times 3 equals 144 girls. Therefore, there are 183 boys and 144 girls in the program. We can verify this is correct because 183 plus 144 equals our total of 327 students. This example demonstrates how the ratio box approach works just as effectively with larger, more complex numbers. Notice how the process remains the same regardless of the difficulty level of the problem. Let's summarize what we've learned in this chapter. For fractions and proportions, remember to set up ratios correctly, ensuring each part aligns properly. Use cross multiplication to solve proportion equations efficiently. And for multiple choice questions, consider plugging in answer choices when it's faster than solving algebraically. For the ratio box method, start by identifying the ratio and total value. Calculate the multiplier by dividing the total by the sum of the ratio parts. Use this method specifically for ratio problems where you know a total value. The ratio box helps you organize calculations and visualize the problem systematically. As next steps, practice with a variety of problems to build your confidence. Learn to recognize which method direct proportion or ratio box is most appropriate for each problem type. Master these techniques as they frequently appear on standardized tests like the SAT and ACT. With practice, you'll find these ratio problems becoming easier and more intuitive to solve. In our next lesson, we'll dive into percentages. You'll learn how to convert between fractions, decimals, and percentages and apply these skills in real-life contexts. Thank you for watching, and keep practicing your ratio skills.